Okay, so here's some things that we can pick up from looking at the first derivative of a function, and it's really kind of interesting. So here's what we're going to do. We're going to talk about where f increases, where your function increases, and it increases as long as you increase x value. So you go from like 1 to 2 to 3, or -1 towards 0, or something like that, where your x values are always increasing. And if your x values are always increasing, the matching y values always increase. That's an increasing function. F decreases if your x values are always increasing, so you're going from -1 towards 2 towards 10, but your y values now, instead of growing up, are now growing down. Okay, and so if that happens, your function decreases. Well, here's a cool thing. If you look at your derivative, wherever the derivative is greater than 0, your original function increases. And wherever your derivative is less than 0, your original function is decreasing. That's really cool. Also, wherever your original function or wherever the derivative is actually equal to 0, then you're looking at a constant at those places where it's equal to 0. So this is really some really neat stuff that's going on here. And then the last little tidbit is, if you have two derivatives and they equal each other, like if you have f prime of x and it's equal to g prime of x, then there's some constant that gives us our original function, that we get the same function, but there's a constant difference. Like, for example, if I take x squared, okay, as a function, and x squared plus 3 as a function, the derivative of both of those is going to be 2x. Okay, so even though the derivative is the same, the original functions differ. So that's going to lead us towards a bigger pot of stuff here in just a little while. Okay, well, let's check out this example down here on the bottom. X cubed minus 4x. We want to know where this is increasing or decreasing. It's really easy. Find the derivative, 3x squared minus 4. Set it to be greater than 0 and set it to be less than 0. And where those things happen, that's where your original function increases or decreases. So on the left here, where we've got 3x squared minus 4 is greater than 0, when you solve that guy all the way down, taking all the steps necessary, and you square root both sides, then you're going to find when values of x are less than 2 over the square root of 3 units away from 0, you're going to have an increasing function. Okay? Where if you work out the other side, you're going to have the same kind of situation where you've got x squared is less than 2 square roots of 2 over the square root of 3. So in between -2 square root of 3 and +2 square roots of 3, if you look on that right-hand side, that's where you're going to have a decreasing function. I think on the left I miswrote it. I've got x is greater than, and it needs to be greater than the whole way. So we could actually be greater than 2 square roots of 3, 2 over the square root of 3, or less than negative 2 over the square root of 3. I didn't put my negative sign on that very, very bottommost answer. And so that's where this function is increasing or decreasing. And if you figure out on your calculator the decimal value for 2 divided by square root of 3, and then you look at your calculator of the original graph of the function, those max and mins are the increases until you get to that max, and it decreases until you get to that min of the original function, and those values will match what we just discovered. Okay, so here's where are you increasing from -infinity to -4 square roots of 3, and from -4 square roots of 3 to infinity. Where are you decreasing? You're decreasing from -4 square roots of 3 to +4 square roots of 3. And you can leave it like this, or, I mean, we know what the square root of 4 is, it's 2. You could write it like that as well. So increasing, decreasing behavior, just use what we know about greater than and less than, and let's just find those values where it makes a statement true.